Okay, everybody. So, as I shared and as I promised this morning, now I'm back in this channel and I mean, yeah, I will do the today's coding practice from now. So, I already picked up the questions. I will share my screen. So, this is my today's question. Okay. So, wait a minute. Okay. So the question is called multiply strings. Given two non-negative integers num1 and number 2 represented as strings, return the product of number 1 and number 2 also represented as a string. You must not use any built-in big integer library or convert the input into integer directly. Okay, so quite a simple question. And obviously, what I can do without this warning is that I just have to convert this number 1 into string 2 into integer 2 and string 3 into integer 3 and multiply 2 and 3 and I get 6 and then convert it into string 6 and I can return it. So obviously, it isn't allowed to use because it makes the question too simple and easy. So I have to think of the way. Okay. So I think even so, I'm not allowed to convert the number into string, no, string into number. I think I'm allowed to, yeah. So my understanding here is that it's okay that I convert the final result integer into string. And also in my understanding, it's okay that I, you know, convert one digit integer like 9 into one digit string into integer. Yeah, I think this is allowed. So, oh, yeah, otherwise I cannot convert the string into the number at all. Maybe I can use the hash map to, hard code the mapping. Yeah, I think I think it is allowed to do in this question. So that being said, let me see. Okay, let me think. So let me think with some examples. So when I have, say, 1, 2, 3, and 4, 5, 6, yeah. So obviously, I can think I mean, when I was in elementary school, how did I calculate this number? So what I remember is that I first recalculate 6, 2, 3, and 2, and 1, then 5, 2, 1, 2, 3, and 4 with 103 to 1 in this order, and then calculate. Then calculate the sum of three inter I mean intermediate intermediate result to get the final answer. So I can apply this answer, apply that approach in this question, I think. And also I think, or I can say, I I have to calculate each combination of any number from the first number. Any digit from the first number multiplied by any number from the second number. not, I mean number two. And I have to calculate every combination of these two pair. And then I calculate the sum of them. And also I have to take care where that number will be, where that calculated, I mean, result should be in the final result. So I can think of it in this way. So for example, when I calculate 3 with 5, the result would be 15. And also I have to think that 5 is actually 50. So this should be 150. So I can think of it in this way. So 3 should have, yeah, 0 power of 10. And also 50 should be 5 and the first power of 10. So I can say digit and power. Yeah. So in this way, okay, so I can convert 1, 2, 3, and 4, 5, 6 into these array. Yeah. And then I calculate each combination, each pair, every pair of these two arrays. And the difficulty here is that after calculating it, I have to think of the carry up. So say when I have 3 and 6, I get 18, 0. This means that the power of 10 is 0, so 18 is considered as it is. However, this one should be carried up. So yeah. Oh, goodness. So okay. So yeah. The Yeah, this should be carried up, so I have to think how I can do it. Because otherwise, I mean, yeah, okay. And hopefully, I'd like to do the carry up only one time. So say if I have the final result is like 2, 4, like this, like this way, I have to carry up in this order. Yeah. So power is here is power 0 and here is power the biggest power. And I have to carry up. So please think that firstly I get this number result, and then I get this number result and this number result. In that case, I have to carry up these two, maybe another bigger position, and then this to this position. And what I mean is it's not efficient. I try to add the pair multiplication in this position first. And after getting all the results, which should be in this power 0 position, then I carry over into here. Then I also increment it with any possible pair which ends up with power 1. I mean, sorry, first power. And in that way. So I mean, I'd like to calculate the result in this order. Okay, so that being said, the good approach is that yeah, so okay. I think I can code it in that way. So for first three, okay, first three I converted them for each power calculate. Then finally I will join, or I mean concatenate, yeah, return number. So that's how it works. Okay, so firstly, so this index im implies signifies I mean, this should be 0, this should be 1, this should be 2. So actually, this is iterating. This should be re iterated in a reverse way. Let's see if this works. And then pen digit 1 and power. Okay, and I will do the same thing for num2. Okay. And then let me see. So hmm, oh, I actually don't have to think of the order that number is filled in. I just have to calculate all of them, and maybe it could be like 12, 15, 125. But after that, I just have to carry up in this order. Yeah, from backward in this XYZ example. So I just have to take care of it. And so let me see. Hmm, okay. And also the one more challenge here is I'd like to put it in this here with, and each index should represent the power of the final result of that number. But wait a minute, so but the problem here is that how hmm, yeah, I think it works. Yeah. Okay. So and the good thing is that as long as I make the iteration in like I pick the number one from digit one array. I mean the first element and then move it in this order. The good thing is that I don't have to fix I mean number length of this array beforehand. I just have to append the new element to this list and it works. I mean, it doesn't happen like when the array is like zero and I have to put the like in its maybe nine or something. It doesn't happen. So let me see. Oh, and let me quickly tell you the time. Let me quickly do the complexity analysis. So in this case, length is 200 and 200, so there could be, I mean, firstly, to build this array, it takes 200 times at max, and 200 times again for num2. Then after that, I have to calculate each combination. So it should take this much, I should say. Yeah. Okay, so firstly, to convert num1, num2 into arrays, it will take all of n. I just have to traverse the array twice. And then for step two, I have to calculate each combination of num1 and num2 digits, so it should be n squared. And for step three, um, yeah, I just have to, carry up, carry up, carry up forever. And it could take at max n squared. Think of the case this here is 999 times 999. In this case, this is almost 1000 and this is almost 1000. So it's actually at max, it should be n plus 1 squared. I mean, the range of the resulting, I mean, number of digits of the result should be less than or less than or equal to n plus 1 squared, which is n squared. So the time complexity should be O n squared. And the same for space complexity, because as I said, the final result could be n squared length, so it should be the space complexity also. Yeah, it can be, I mean, resulting digit can be that wrong. Okay, so that being said, wait, this is good enough. And power should be power 1 plus power 2. And the digit should be d1 times d2. And that being said, I have to put this digit into the appropriate position in this array. So, oh, I can do it in this way. So say if I'd like to put I mean, if the current length of the array is 0 and if I'd like to push index 2, what I have to do is I have to put something, I mean 0 three times. Yeah. Okay, so I think this works. The ranks of the resulting digit array minus one should be, if it is smaller than or equal to power, I have to put more space. Yeah. Okay. So after that, I will do, yeah. Then what I need to do is I have to carry up the digits. So I think good idea here is I think good idea here is I prepare the another array, another new array, and current. So in this way, I can increment current sum and the least digit should be the current digit, which should be put in the digit of the carry up array. And then I have to carry a current sum divided by 10. And then when go to the next digit, the new number appear and it is added to the current sum. So I think it works in that way. And now I've got the resulting digit up to carry up, so I have to concatenate that. One thing I have to take care is that I have to reverse it and also map it. Okay, then I will return it. Yeah, I think this works. Let me check quickly. So digit one, digit two is something I have to first rebuild, and it should have power. It should be the list of tuple, which consists of power and digit. So digit first and power then. Yeah, it doesn't matter. And resulting digit, so this should store the calculated multiplication of each pair of the digit from two numbers, power 1, power D1. No, yeah, let me swap it. Yeah. So power digit order, it is iterated, and power should be the sum, and this should be the multiplication. Then, if the ranks of the resulting digit is too short, I will expand it with 0. Then I push the append. Then I will register the digit as the appropriate position. Then I have to work on the carrying up. So I think it works in this way. Yeah, power digit. Okay. So yeah, I pop pop. I take a look at the digit in the resulting digit array and yeah, store it in the digit of the carry up array. Okay. Then finally, I have to reverse the digital to carry up array and then convert it into the string array. I mean, yeah, list of strings. This is actually the single character, and then I have to join it and return it. Okay, there's a typo. Ah, and here I will convert it into, yeah, integer. Just in case I will assert the D1. This is an excuse, kind of excuse and proof that I convert only one single digit into string. The one character string into digit, not write 23 to 23 integer. It doesn't happen. Oh, so why is it? So ah no power digit. Oh, sorry, this should be one. And also it complains that resulting digit. Oh, I didn't put power anymore in this resulting digit array, so I can, yeah, this is, I mean, this, yeah, I can't unpack it, obviously. Okay, and I have one more thing. So, oh, sorry, this should be the modulo of 10 because I have to guess the least digit in this number. Oh, wait, so it doesn't work yet. So if current sum, maybe it ends up with zero some number. So it means so. Okay, so I will continue this one. Yeah. So if current sum is still larger than zero, I have to do this process. Okay. Keep doing this process. Oh, so I think it's confusing, maybe. Ah, okay. So I have to map it. So probably I have to. So it's a bit confusing. So let me change. I mean, let me split this into two lines or three lines. So firstly, I have to map it in. No. Firstly, I have to map it into. Firstly, I reverse it and then I have to map it. So then I will join it. So that's how it works. Okay, let me check it again. So there's a trading zero. So where is it? It's because I added unnecessary zero. Hmm, I see. Interesting. Yeah, obviously to avoid this, I think maybe this is the best solution, but I can pop it out from this stuff to carry up. Yeah. Okay, so now it works. So let me submit this code. No, it doesn't work at this point. So list index as a range, probably here. Sorry, so this should be larger than zero. Ooh, okay, so this is an interesting edge case. So I cannot pop out. So if digit have to carry up is only a single character, which is zero, so I have to make it in this way. We can say there should be larger than or equal to 2. Okay. Okay, so now it works. So ideally, I should discuss. I should write the test cases if I have enough time. But for this question, it is quite simple, so skipped it. And I already explained the time complexity and space complexity. Both of them should be O(n) squared. Yeah. So I overlooked some edge cases here. Yeah, probably. Yeah, especially this edge case. And made some small mistakes, but overall, I could solve this question. So I finished my today's coding practice. Yeah. See you tomorrow. Bye.